Hello and welcome to Unit 1, Day 7. Today we're going to talk about the histogram. So our goals today, we want to learn how to build a histogram, then we want to learn how to analyze and interpret a histogram, and then we want to recognize the shape of a distribution from a histogram, and then we're going to compare and contrast a histogram and a frequency table. All right, so these are our main goals for today. So we're just going to get right to it here and start with building a histogram. And believe it or not, the histogram and the frequency table are very much related. So to build a histogram, you are going to want a completed frequency table to help you out. All right, so we're going to start with that. And what I have here, I have 50 pieces of data. The data are the weekly paycheck amounts of 50 Centennial seniors who have various jobs around town. You see all my typos there, which is great. So they have various jobs around town. We want to construct a frequency table, and they tell us that they want a lower class limit of 75. All right, so no problem. So if I'm thinking over here, here's my classes, right? Weekly paycheck amounts, and this first lower class limit is going to start at 75, and it's going to go from 75 to something. So I got to figure out. First off, I need to figure out how many classes I want, and I'm going to choose 7 classes for this one. All right. Now, typically when you choose the number of classes, the normal or the accepted standard in the statistics field is to choose at least 5 classes. So you want at least 5 or more. So I'm going to choose 7 classes. This is a pretty good number, but you don't want to go any less than 5. All right, so we're going to choose 7 classes here. And then we need to figure out what is our class width going to be. All right, so how wide are we going to make these classes over here on the left? And the way that we calculate that, there is a specific method that is stated in the book, and Mr. Slifer went over it last week as well. So I'm going to say class width is equal to the max minus the min divided by the number of classes. And then once we do this calculation, we typically want to round up to a nice number. All right, so this is what we're going to end up doing. So I'm going to look through my data here, and I'm going to find the smallest value, and I'm going to find the biggest value as well. So I'm going to go through here, and I believe my smallest value is 75. Right, so 75, that's our smallest value. And then our biggest value, if I scan through my numbers here, I see a 206 over here, and I'm not seeing anything bigger than 206. So my max is 206. My min is 75. So I'm going to subtract those two. I chose 7 classes, so I'm going to divide by 7, and what you're going to end up getting here is 18.71. All right, so the next step here is to take this ugly number, right, and round it up to a nice number. Now, strictly speaking, most people would round up to 19, but you can round up to something even nicer. So you don't have to go to 19. You could round up to 20. All right, 20 is a nice number to count by, so I'm just going to go ahead and round up to 20. And like I said, this is one of the things about stats. You get to make a lot of decisions. There is really no rigid way that you have to make frequency tables. You're going to see them made in all different types of ways. All right, so you could choose 19 here. I would say go ahead and just round up to 20 and count by 20s because it's easier. Okay, so that means if my class width is 20, then my next lower class limit here is going to be 95. Okay, and then we'll go up to 115, and then 135. 155, 175, and 195, right? So I want to make sure I have 7 classes. So I got 1, 2, 3, 4, 5, 6, 7. So there's my 7 classes, and then I need to figure out my upper class limits. Now, since this is 95, this should go up to 94, right? And then I would count up by 20s to get the rest of my upper class limits. So 94 plus 20 would be 114. Right, and then we would do the same thing for each subsequent upper class limit. So this would be 154, 174, 174, 194, and then 214. Okay, so we have our classes set now. Now, this next part is the tedious part. We've got to figure out how many of these paychecks ended up in this range here from $75 to $94. And I'll do the first class with you, and then I'm going to fast forward through the rest because you really don't want to sit here and just watch me count things out. All right, so I'm scanning for any numbers that are in between 75 and 94. That's above 94, so here's a 75. So as I find them, I like to cross them out. So that's one. Nope. Yep, 2, 3, 4. Right, so I got 1, 2, 3, 4, and I cross them out as I find them. That way, when I go to the next class, I don't have to look at those ones again. I have less to scan as I go through these. So my frequency is 4. All right, then I would do the same thing for the rest of these classes. All right, now to figure out the relative frequency is the percentage of data that falls in this particular in this particular interval here. So I would take 4 and simply divide it by 50, right? Since there's 50 pieces of data, and what you're going to find is that is 8% of the data, right? So I'm going to say my relative frequency is 0.08, and then I would repeat that for the frequencies that I find here. All right, so I'm going to go ahead and write down the rest of these frequencies, count out the rest of my numbers, and get this table filled in. Alrighty, so I've got everything filled in, went through, counted my data, so I've got all my frequencies, all my relative frequencies over here. Just a little note on the MyOpenMath side of things. The relative frequency should be rounded to 3 decimal places. For most of these calculations that I did here, there was no need for third decimal places. They landed right on 2 as I did the calculations, so this would be like 0.080, 0.280. There's no need to put a 0 on the end there, all right? But if it does carry more decimal places, take it to the third decimal place. Most of those relative frequencies that you see on MyOpenMath are going to round to 3 decimal places, all right? So just some typical questions, common questions that we get about frequency tables. How many classes should I choose? Remember, it's a minimum of 5. Okay. So if you're ever just making one from scratch, not on MyOpenMath, you want to make sure that you choose 5 classes or more. All right, and then how do we do the class width? Well, we just saw that calculation, right? So that's max minus min over the number of classes. All right, and then you're going to round up. And you can choose to round up to the next integer, or you can round up to a nice number. So the problem that you're going to see in your practice set today, it's going to have you round up to a nice number, not necessarily the next integer. The one that Mr. Slifer had you do strictly had you round up to the next integer. All right, so it just depends on what the requirements are for the question, but make sure you pay attention to the instructions in MyOpenMath. All right, now where do we start our first class? You can choose the minimum. So some people just like to start at the minimum value for their first lower class limit, or you can start at something close to the minimum. Right, you want to choose something close and less than. Right, I know that sounds very non-specific, and it is, and it's one of the frustrating things about stats. Like I said, there's no rigid way, right? Every textbook you read is going to have a different method for doing this, but I say something close and less than. So like, let's say your minimum is 72, you could choose to start your first class at 70, right? It's less than, and it's something close to that minimum value, right? Or you could just start it at 72. It really just depends on your preference. All right, some people like 70 because it's divisible by 10, right? And then you might set a class width of 10, so that way you're counting right on the tens, all right? So really it's preferential, all right? The class boundaries, this is another one that tends to confuse students. What are the class boundaries? Remember the class boundaries, I'm going to go up here to kind of discuss that. Class boundaries exist in between the limits, okay? So for instance, this is an upper class limit and a lower class limit. There is a gap in between those, right? Going from 94 to 94.5, there's a gap there in between, right? The class boundary exists in between those two limits. So this would be 94.5. It would be the midpoint between these two numbers, all right? And another thing that confuses students is there is a class boundary that comes before the 75. That would be 74.5, right? So if the midpoint is at 0.5 or 94.5 in between these two numbers, then it's going to be 0.5 before this first number as well. So that first class boundary is 74.5. All right, just wanted to clarify that because I got that question quite a bit on the last homework set. So class boundaries, how are they different? I like to think of them as the numbers in between the limits, right? They exist between the limits. All right, and that's where I will leave that. Now let's use this frequency table and make this thing called a histogram. Now when you initially see this thing, you're going to say that looks like a bar graph, but there are some distinct differences between histograms and bar graphs. All right, so let's start when we talk about histograms, we're putting this thing on a graph. So there is a horizontal axis and there is a vertical axis, and the horizontal axis is marked with our class boundaries, right? Not the class limits. It's the most common mistake that students make when they make their histograms. And like I said, every textbook is different, so you might open up a different textbook and they might use class limits. For our textbook at Parkland, we are using class boundaries. All right, so our horizontal axis gets marked with those. So our first class boundary, like I said before, was 74.5, right? And then the next class boundary would be 94.5. That is the number in between those two limits, right? And then from there, you can just add the class width to these tick marks here, right? So I'm going to go to 114.5, to 134.5, so forth and so on. Okay, so I got these all marked with my class boundaries, and then the vertical axis over here is going to be marked with the frequencies. All right, so I'm going to go up by twos. I'm going to say 2, 4, 6, 8, 10, 12, and 14. All right, so now I've got my horizontal axis marked, I've got my vertical axis marked, and I'm going to put labels on these things, right? So graphs need labels for context. No one's going to know what these numbers mean unless you label them. So this is going to represent the frequency, and these will represent the weekly paycheck amounts. All right. So now I got that labeled. The other thing that you need to make sure that you put on your graph is a title. So I'm going to title mine Centennial Senior Paychecks. All right. So we got a title. Axes are labeled. I've got the numbers in the scale set for each horizontal and vertical. And now what I'm going to do is I'm going to draw bars to represent the frequencies. All right, so for our first class, right, in between these two boundaries, we had 4 paychecks. Let me switch colors here. Green, I think green is good. So we had 4 paychecks that were in between $75 and $95, right, indicated by our boundaries of 74.5 and 94.5. So I'm going to draw a bar just like this, and you might shade it, right? You would color it in. If you were making this for a professional presentation, you would make this with rulers and make it all nice and straight. In fact, you'd probably use a computer software program to help you make this histogram so it's nice and perfect. But I'm showing you how it's built from scratch. All right. So the next class, going from 95 to 115, had 14 paychecks in between those two values. So we have a bar here, and like I said, I'm drawing this by hand, so it's going to be a little sloppy. That's okay. Okay, so like I said, if you were doing this, you would be using a ruler, right, and coloring it in a lot nicer than what I'm doing here. Right, so there's our second bar. I'm going to do one more bar, and then we'll fast forward a little bit. All right, so the third class going from 115 to 135, according to our frequency table, had 6 paychecks. So I draw my next bar like this. Oops. Go. And then shade. Right. And I'll finish constructing the rest of this and fast forward for you. All right, so I've got my histogram all drawn here. So this would be the finished product that we have here. And again, just reviewing some of the things that we should know about histograms. The horizontal axis is marked with class boundaries, all right, so not class limits. The vertical axis is marked with the frequency. The bars should touch. There should be no gaps in between the bars. That's one of the big differences between a histogram and a bar graph, right? Bar graphs are totally different and typically deal with qualitative data, whereas histograms deal with quantitative data, all right? So the bars are going to touch on the histograms, all right? You should have titles on everything, and they should be labeled, right? That's very important. And histograms typically are used to allow us to see the shape of a distribution, All right, so we can kind of see a shape forming from these bars, and we're going to talk more about the shapes here in just a minute. Okay, so that's the big power of the histogram, is the shape. Allows us to see what shape our distribution is. All right, so let's do a little bit of analyzing of our histogram, right? So some of the questions that we can answer just by looking at a histogram. So we can say, okay, well, how many students in our sample make at least $175? Right, so I'd go up to my histogram here and I'd say, okay, 175 starts here with this class, right? So this is 174.5, which is the class boundary for the class that starts at 175, all right? So this bar has 175 to 195, right? And then since we want at least, we would also want the number of students in this bar, right? So there's 6 students here in this class and another 5 here in this class. And if I add those 2 bars together, I get 11 students, right? So there's 11 students that make at least $175. Now this one says how many students make less than 115. Right, so I go up here, so 115, that would be here. So this bar has 115 to 135, so we want less than 115, so we want the 2 bars over here to the left, right? So there's 4 in this class and 14 in this class, so there's going to be 18 students that make less than $115 every week, right? Now this one says how many students make in between 135 and 155. Okay, so I'm going to go back up here to my histogram. So remember, 135 starts here at this class boundary of 134.5, and then 155 is here, right? So we're looking for a between. So we're just actually looking at a single class, which is this bar right here, which is 9. Okay, so we'd say there are 9 students that make in between 135 and 155. This one might have been easier to answer from the frequency table. You could answer the same questions from the frequency table, but the histogram does tend to make it a little bit easier. All right, and now this is the powerful question. This is the kind of question that we're going to be trying to answer all throughout the semester. And it is answering the question of, what is a typical amount of money that a Centennial senior makes in a week, right? That's a very powerful statement to make. If I said seniors at Centennial typically make, I don't know, $150 or $180, you want to have your data back that up. All right, we're going to talk about how to do that throughout the semester, but for right now, just by looking at the histogram, it can be a little bit difficult to tell. All right, typically when we look at a histogram, the typical amount is where all the data tends to peak, right? Where we have the most data in our histogram. And it's kind of hard. We do have a peak right around here, so you might be willing to say, well, they make somewhere in between 95 and 115 a week. But there's a whole lot of data over here too. So this one is kind of hard to tell. All right. So it's not a question that we can definitively answer just by looking at a histogram. Right. So let's look at the different shapes. We talked about these shapes before. All right. So the shape that we all covet and the one that we want the most is this shape right here. We call this the normal distribution. This is what we call a normal shape. And it's indicated by a bell. Right, so if you've ever heard the term bell curve, this is where it comes from. This is what a bell curve looks like. Okay, it's symmetric, right? So that way you have half the data on the right and half the data on the left. All right, and it tends to increase to a maximum and then decrease, right? Making that nice smooth bell shape. All right, so this is a really nice thing. And when it's like this, when you get a nice perfect bell shape like this, remember that typical amount that we're looking for? It's about right here, right? This is where we would find that typical amount. So we didn't get that nice shape from our histogram, which is why it was kind of hard to tell where the typical amount would be. But when we have a really nice normal shape like this, it's easy to tell where that typical amount is. All right, so this next histogram that we're looking at, this one here in red, this is what we call a uniform distribution, and it essentially makes a rectangular shape, right? And this is happening because every single class has the same frequencies in it, right? There's no variance going on here. So when we look at this, there's no way to tell what a typical amount would be because the data is evenly spread across all of the possible values down here on the horizontal axis. All right, so that's why we call this uniform. Again, the key characteristics here, it makes a rectangle. All of the classes typically have just about the same amount of frequencies. All right, so the frequencies are typically the same throughout the different classes. All right, next one here we get skewed. These are called the skewed histograms. And so when something is skewed, you typically have like a hump of data on one side or the other with a tail extending in a particular direction. So in this graph right here, we have a tail that extends to the right. So when the tail is on the right-hand side, we say it is skewed right or skewed to the right. Okay, so that's when the tail is on the right. Now, if the tail, like this one here, extends off to the left, you see our tail extending off to the left, this means it is skewed left. All right, so it's a little bit backwards. Some students get confused because they're like, well, the hump of data is on the left, so isn't it skewed left? No, it goes based on the tail. All right, so wherever the tail is, that's how you tell which direction it's skewed. Okay, so this is skewed right, this is skewed left. And even skewed data is kind of nice because you can still see that typical amount when we have that nice clustered peak. That's what we're looking for to determine typical, right? If I were saying, what's the typical amount for whatever this represents, I would say that's over here in between, like maybe 18 or so is the typical amount, right? So, and then same thing on this one, we could say the typical value is here. All right. All right, last shape I'm going to talk about here is what's called bimodal. Bi, right, is a word that means two. Okay, so what that means is when we look at our histogram, we're going to see two distinct peaks, right? Peaks being these guys right here, so you can see the two distinct peaks. That's how you know that you are looking at a bimodal histogram. And if you had more than two distinct peaks, you could have three, you could have four. In that case, we would call it multimodal. And you can see, again, my typo there, not mullet modal, but multimodal is what happens if we had more than two peaks. All right. Okay, guys, I hope you found that video helpful. If you have any questions, make sure you ask me in the Zoom chat. Give the practice problems a try, and have a great day.